Okay, here in number 5, I'm asking you for an exact volume. So if you want to use your calculator, great, but you're still going to have to give me an exact answer. So you're going to have to do some thinking on your feet. We're taking this back around the x-axis again, and it's trig. Y equals cosine of 3x. I know that if I put a 0 in, the cosine of 0 is going to be 1. Even with that 3 there, that 3, as you may remember from honors pre-calc, affects the frequency in the period, not the amplitude. So it's still going to be at the point 0, 1. It's going to fall, go below the x-axis, and then keep doing its thing. I don't really have to go any farther because 2 of the borders are y equals 0 and x equals 0. So that's going to keep me in quadrant 1. Those are the coordinate axes. And x equals pi over 6 is a horizontal, or a vertical line, I should say. I have a feeling it's right here. Of course, I also have a feeling it's right there because I wrote the problem, which helps. So what's the real reason that we know that it crosses at pi over 6? Well, if you put a pi over 6 in for x, right here, you're going to get the cosine of pi over 2, which is the cosine of 90, and that is 0. So, yes, we know that these points are 0, 1, and pi over 6, 0. So that's my region. It's an almost triangle. It's a triangle with a curved hypotenuse, if you will. Now I'm going to take that thing and I want to go around the x-axis. So when I do that, it's going to look something like that. Let's throw a representative rectangle into the mix, and we'll see what we can do. That entire region touches the x-axis that it's revolving around. So therefore, we are, once again, back to disk method. So we just need a single radius, and the radius is going to be top minus bottom, which in this case is 0. So it's just going to be cosine of 3x. All right, so we can write our volume formula. Here we go. The volume is going to be disk method, so pi, I'll kick that out. We're going to integrate this from 0 to pi over 6 along the x-axis. And it's going to be radius squared dx. And of course, the radius being cosine of 3x, that's going to get squared, so it'll just be cosine squared 3x is how we like to write it. I'll put some parentheses around that just for fun. Oh man, this is one of those half-angled derivations. I don't know if you remember that. We were working in the middle of, I think it was chapter 5 or maybe it was 4. We were on a worksheet and we came across these and we had to square both sides and do half angles and rewrite the integral. And then I said, you know what, this happens so often in real life that you probably just want to memorize the answer. Here's another instance of it. Let me bring this pi down. Okay, there's the pi. And the answer to the integration is 1/2 x, always, always, always. Maybe you remember this now. Sine would have been the minus, but this is cos, so it's a plus. It's not 1/4, it's 1/12. Normally it's 1/4, but the bottom gets a 4 times 3 because there's a 3x. It's always sine. Regardless of whether this is sine or cosine, the answer is always going to have a sine in it. Because the golden sheet has cosines all over the place, and you have to integrate that when you're going from scratch. It's not 3x, it's twice as big, it's 6x. Back in the day we had plus c, but here we have a definite integral, so we're going to plug in the pi over 6 into 0. Wow, what an incredible time saver that was. I would have had to rip out a new sheet of paper and reinvent the wheel if I didn't have that memorized. So now we're going to plug stuff in. Okay, pi over 6. Half of pi over 6, that's pi over 12. Pi over 6 going into here makes a pi. Sine of pi is 0, so that second half just dies off. And if you plug zeros into both places, you're going to get another 0 plus 0, so that's that. And the exact volume is pi squared over 12, or 1/12 pi squared. And as always, that's cubic units. Okay, number 6 says find the exact volume. So again, we want an exact answer formed when we take the region and we revolve it about the x-axis. All right, so let's take a look and see what the region looks like. It's a secant. Oh boy. It's a secant of x over 2. So I kind of have to think about this. We do know that it goes between negative pi over 2 and positive pi over 2, so I can fill that in first. Those will be vertical lines. And of course, y equals 0 is the x-axis. So the secant graph is going to form the top portion of this bounded region. So let's try some things in. If you take a 0 and you plug in, that'd be the secant of 0 over 2. Secant of 0. Well, secant's the reciprocal of cosine. Cosine of 0 I know is 1, so the reciprocal would be still 1. So 0, 1 is on the graph. Let's go ahead and try the pi over 2 in. If x is pi over 2, then you're looking at secant of pi over 4. The cosine of pi over 4, or cosine of 45 degrees, is rad 2 over 2. That means that the secant of pi over 4 would be the reciprocal, which, once you do a little bit of algebra 2, comes out to be rad 2, or 1.414. That's right about here. Putting a negative pi over 2 in will give you the same thing. So the graph's going to look like this. Eventually, by the time you get to pi, it's going to be an asymptote. Same thing with negative pi, it's going to be an asymptote. Because the cosine of pi over 2 would be 0, so the secant won't exist. But we don't care about the asymptotes. We have our region now. I'm going to color it yellow. All right, we're going around the x-axis. I hope by now you can tell that this is disk method. So the volume is going to be pi r squared. I'm going to throw a 2 in there. I'm going to use symmetry, 2 pi. Since I need an exact answer, I'm going by hand. So instead of starting at negative pi over 2, I'm starting at 0, much easier. I'll go to positive pi over 2. What am I integrating? Well, I'm integrating radius squared, and the radius happens to be secant. So secant, I'll just throw the squared in the middle, and it's the secant of x over 2 dx. All right, just to play it safe, I am going to employ a u sub here. I don't want to miss the problem just because I'm getting careless or sloppy. I'm going to call u just simply x over 2, or 1/2 x. So du would become 1/2 dx. So it's not much of a u sub, but it's just to keep me safe. So I need a 1/2 on my dx. I need an extra 2 out front. A lot of people who don't use this u sub don't have the 4 pi. They have a 2 pi, and they wonder why their answer is half as big as it should be. And I know why. They didn't use sum it. All right, that's going to be a du. This will simply become secant squared of u. Remember, I don't write the limits of integration because the 0 and the pi over 2 were x limits, not u limits, so they're going to stay off just for now. Oh my gosh, you guys, secant squared of u? You know what that is? When you integrate, that's tangent of u. Remember, the derivative of tangent, secant squared, we're just going the other way. So we have 4 pi times tangent of u, but I'm going to put the u back in. Remember, it's x over 2. And now I can put my limits of integration back on. And we can get ourselves an answer. Okay, 4 pi out front. Putting the pi over 2 in, cutting that in half would be tangent of pi over 4, which is 45 degrees. Tangent of 45 is 1 from the golden sheet of trig. Put the 0 in, cut that in half, it's still a 0. Tangent of 0 is 0. which means I don't need the bracket because it's a 1. And the answer is 4 pi cubic units. And that is an exact answer. No reason to ruin it on a calculator and lose accuracy. That's perfect. All right. Lastly, we have number 7, parts A and B, free response style. It says let S be that shaded region bounded by the top graph, which has an exponential in it, and the bottom graph, which is linear, and of course on the right by that vertical line, x equals 1. Find the area of S. Well, this is pretty straightforward. We're going to go top minus bottom. Let me go ahead and put one representative rectangle in here, just to be able to see it. Some people like to have this, some don't. This is x comma y, like all points are, but you're on the line, so y is negative 1/2 x. Up here, this is x comma x e to the x. So the length of that line, again, as I said, would be top minus bottom. You're going to have a minus negative. So the area will be the integral. And again, these tiny little rectangles start at 0. They get bigger, bigger, bigger until the last one is at 1. So we're going to integrate from 0 to 1. No pi in front. We're not whirling around an axis. We don't have circles. These are just rectangles. Top minus bottom. So x e to the x minus negative 1/2 x. That's going to be plus 1/2 x dx. And the first part is integratable by hand, but neither AB nor BC have learned how to do that yet. So for the moment, this is a calculator problem. So you would just type that in, integrate from 0 up to 1, and you get a really nice answer of 5/4 or 1.25 square units. Okay, so that's part A. Part B uses the same picture, but instead it says write but do not evaluate, which I like, an integral expression that gives the volume when you take this shape and rotate it around the horizontal line y equals negative 3. And y equals negative 3 is going to be down pretty far enough that the shape will not touch it at all. Obviously, we're going to have a washer method problem here because of the gaps. I'm going to put that representative rectangle back into the picture. That will help us. All right, so when we go around y equals negative 3, you're going to see the washer. It's going to go off the page here. And so the large radius is going to be the distance from here down to the axis of revolution. That's capital R. And the inner radius, lowercase r, is the distance from here down to y equals negative 3. That's small radius. All right, let's find both of those, starting with the outer radius, capital R. Well, so how far is it from here down to here? Well, it's top minus bottom. It's top minus negative 3. Well, that's going to be plus 3. So the outer radius is x e to the x plus 3. All right, moving to the light purpley magenta lowercase r, the inner radius. Again, top minus bottom. It's going to be negative 1/2 x minus negative 3, which would be plus 3. Let me write that here. Negative 1/2 x plus 3. So they both have plus 3's in the end. And we don't have to evaluate this. We simply need to write an expression that gives the volume. All right. The volume is pi, and I'll factor that out. Move it out front. We're going to still integrate from 0 to 1. That has not changed. And you know what's kind of cool? Since we have written both capital R and lowercase r, if we simply want to just reference them, as long as I can find it written on the page somewhere, and the same thing, College Board does it the same way. If they see that you've referenced it, you don't have to write that stuff again twice. You do need to write dx at the end. And that, my friends, is a perfectly good answer. That's a great answer, actually. Put a check mark on it. If you do want to write the actual functions in, that's fine as well. Just make sure that you have the proper parentheses around things. Looks good. Write but do not evaluate. The expression has an integral in it. Yeah, all the parts are there. Don't forget your pi in front. We are all set. All right, that was the third and final day of a very tough section, Volumes of Revolution. I think in the AB class, that's definitely top 3 as far as difficulty level, so made it through. Nice job. Cross sections will be next, and that'll just about wrap up AB. BC, you guys are doing well as well. You're more than halfway, so hang tough. See you guys then.